All right, hey pre-calcers. We're going to look at the second example of function composition. This time we're going to look at a mapping. I've got a couple of tables here for my functions. F of x is the table in the middle. G of x is the table over here. So the first thing that I'm going to do is just figure out what is the mapping that would work out for the composition f of g of x. So again, we're going to take the g of x values. That means we're going to take this whole function and plug it into the function f of x here. That's what that means. And then we'll use that and that idea to evaluate some of these statements here. So first of all, I'm going to start by setting up my table. Since I'm starting with the g of x function, that means I'm going to start with my domain 1, 2, 3, 4. That was my domain of the g of x function. So that's going to be my setup here. My input 1, 2, 3, 4. Those are my possibilities. And then for the composition, f of g of x, I'm going to put my outputs here. So how do I figure this out? So what I'm going to do is just evaluate the function g of x for each value in the input, and then I'm going to take that answer that I get for g of x, and I'm going to plug that into my f of x function. So first of all, to start out, that's going to be g of 1. So I'm going to think of g of 1 first, and that g of 1 is just 1. So I'm just going to take that 1 now and plug that into my f of x function. So now g of 1 is 1, so I take 1, plug that into my f of x function, and f of 1 is 2. So my composition is going to have this as its first pair. It's going to map from 1 to 2. All right, so now I'm just going to repeat that process for 2 and 3 and 4 and see what I get. So if I evaluate g of 2, that gives me 16. Then I'm going to take 16 and evaluate f of 16. Well, f of 16 is 4, so my composition f of g of 2 is going to be 4. Repeating that for 3, g of 3 is 4, f of 4 is 3, so I'm going to get 3, 3 is the mapping for this one. Now, we have to be careful whenever we're dealing with compositions, because watch what happens on this when I try this next one. So g of 4 gives me 25. Well, I don't have a table value for 25. I don't have a value of 25 in my mapping here. And so it feels like we're kind of stuck. And that's exactly what we are. We are stuck. So we cannot carry this forward because 25 is not defined. So we are left with an undefined value. So this input of 4 is undefined. And um, we don't have a valid output for this. So this is not a 0. This symbol right here is just a symbol for undefined. So that just means that the value is undefined. All right. So we can also just use these mappings to evaluate statements like this, and you're going to see some in the homework that look like this. So we already kind of did this first one, f of g of 2. We did that. That's just in our table up here, right? So f of g of 2, that's just equal to 4. We already found that. F of g of 4, well, we just talked about that, right? That one is not defined, right? Because g of 4 is 25. F is not defined for 25. We can go the other way. We can use these mappings in other directions. So g of f of 1, in this case, we were mapping it in the opposite direction. So f of 1 would give me 2. So for this one, I'm going to take the 2 now, plug that into my g of x function. G of 2 is 16. And then finally, I have this awful looking statement right here with this repeated composition. So what I'm going to do, I'm just going to evaluate f of 1, then I'm going to take that answer, plug it into g, take that answer, plug it back into f, take that answer, and plug it back into g. So you're just going backwards through the expression, basically. So f of 1, we're going to evaluate that. F of 1 is 2, then g of 2 is 16, f of 16 is 4, and then g of 4 is 25. So uh, that full expression would just give me 25.